Hey guys, welcome. Yeah, so a while back I provided you 6 examples. That's to say, I made 6 different videos on how to use L'Hopital's rule in a variety of situations. But recently I came across 2 good examples, so I wanted to provide you additional examples. Here's the first of them. Alright, so here, if you tried to evaluate the limit as it's written, you'd substitute for x with a 0, right? So that'd mean that you have this here. Now, 0 to the 5th is 0, and 0 to the 10th is 0 also, right? So in the numerator, you'll have 1 minus cosine of 0, and cosine of 0 is 1. So in the numerator, you'll have 1 minus 1 divided by 2 times 0, and therefore divided by 0. That's 0 over 0, which means that you could apply L'Hopital's rule. And L'Hopital's rule says that instead of this original limit, we can take the limit as x goes to 0 of the derivative of the numerator divided by the derivative of the denominator. And so if we do that, then this is what we'll have. The derivative of the numerator will start with the derivative of 1, which is 0, and then minus, this minus sign is right here. I've highlighted it here so we can keep track of it, right? And then the derivative of cosine x to the 5th is negative sine x to the 5th times, by chain rule, 5x to the 4th, where 5x to the 4th is the derivative of x to the 5th, right? Okay, cool. And so we're complete with the derivative of the numerator and what I have here. We're done. I shouldn't say we're complete. Anyway, math lessons, not English lessons. The derivative of the denominator is going to be just using the power rule for derivatives, right? So that's 20x to the 9th. Cool. So what's new now? Well, this minus minus cancels, so we just have a positive numerator, right? And I wrote the 5x to the 4th first, which is the correct grammar when you have polynomials and trigonometric functions. But yeah, basically I followed math grammar and simplified the numerator, which is right here. And then the denominator, well, is still 20x to the 9th. Now, I'm showing you that the 5 in the numerator and the 20 in the denominator can cancel to a 4 in the denominator. And then the x to the 4th in the numerator can cancel the x to the 9th in the denominator to an x to the 5th in the denominator, which we like, because then if we have to do L'Hopital's rule again, which is take the derivative of the numerator and then take the derivative of the denominator, it will be easier to do that if we don't have to use product rule in the numerator. So cancel this x to the 4th with this x to the 9th to get x to the 5th in the denominator, right? And so that'll mean that this is the limit that you have now after you've done more simplifying, right? And now we try to evaluate the limit, so plug in 0. When we do, we get sine of 0 divided by 4 times 0 to the 5th, but that's going to say 0 over 0 again. So as we feared, we have to use L'Hopital's rule again, which means we take the limit as x goes to 0 of the derivative of sine x to the 5th divided by the derivative of 4x to the 5th. And when we do that, this is what we'll get. Well, first, here's where we left off, and then taking the derivative of the numerator and then dividing by the derivative of the denominator, we get this new quotient, right? And again, chain rule is how I've got this 5x to the 4th here, because the derivative of sine x to the 5th would be cosine x to the 5th times the derivative of x to the 5th, which is 5x to the 4th. And then divide by the derivative of the denominator is, well, the denominator was this here, so 5 times 4 is 20x to the 4th, again, and the denominator, power rule for derivatives, right? Okay, cool. So now it's really nice because x to the 4th in the numerator and x to the 4th in the denominator are going to cancel. 5 and 20 are going to cancel to a 4 in the denominator. So now the limit is x goes to 0 of, we write, cosine of x to the 5th divided by 4. And surely it should work now, and it does. Because if we plug in 0 into this quotient now, we get cosine of 0, which is 1, divided by 4. So finally, our final answer, 1/4. Yeah? All right, cool. I hope you enjoyed this, and at least one more additional example to come. So keep watching. Take care.